6:30.
What?
6:30 is a big time. So, good morning, students. Now, I hope we are clear with the coverage of lines and angles. All of you are clear with any doubts are there? Any doubts are there in lines and angles topic? Chapter 6, what we covered till Saturday? No, no? Shall I go for next topic? All of you are able to hear me? Still we are waiting for our friends to join. Okay, I think we can go for the next topic, and I hope you are clear about your project also. Project work, how to go. Okay, good. Next topic we will go, that is the triangles topic. This is chapter 7, right? So we'll go for the next topic, which is triangles. Right. So already you know what is a triangle. Just we quickly recap what is our previous knowledge about triangles, right? So recap we are going now. Okay. So recap means a triangle is three-sided, triangle, closed. It is called polygon, right? You know, it has three sides and three angles, and it's a closed polygon, right? Do you know this part, this section? You know what is a polygon? You know, closed figure. You know, beginning point and joins the end point, right? And three sides. You know, three angles. You know, so there are 6 parts, 3 sides and 3 angles, right? The sum of interior angles of a triangle is equal to 180 degrees, you know, and then sum of exterior angle of a triangle is equal to 360 degrees. You know, this part we have proved in the previous topic. Sum of interior angles is equal to 180. This only we will call as sum of the angles of a triangle. Angles means the interior angles. That you mean, if you take the triangle like this, you can name anything triangle with vertices. So these are called the interior angles. So this sum must be equal to 180 degrees. Now one more condition for triangle construction or existence of triangle is the sum of any 2 sides must be greater than or equal to third side. Any 2 sides sum must be. If third side is greater than the sum of 2 sides, means sum of 2 sides is less than the third side, then existence of triangle and construction is not possible. Okay, so these are the conditions for all these for the triangle. You know this part. The parts of triangle are nothing but 3 sides and 3 angles. Vertices doesn't come under parts because they are the edges, right? So 3 sides are parts of triangle, 3 angles are parts of triangle. Always there is 1-to-1 correspondence You know this part. Always there is one-to-one correspondence between sides and opposite angles. So this is also very important vertical relation. We'll discuss these parts thoroughly in this chapter because we are studying the concept of triangles in this topic or in this chapter. So we are going to cover all these parts. Some of the angles of a triangle, you know, interior angles, you know, some of the exterior angles, you know, parts of triangle, you know, polygon, you know, closure figure, you know, three sides, three angles, and there is a one-to-one correspondence between the sides and angles of a triangle always. So these parts are, this is the previous knowledge for us, right? Previous knowledge about triangles. Already you learned these things in your classes 6 and 7 and 8. 6 and 8 classes you learned all these things, right? If you want to make a quick note, this is a recap for triangles. Now what we learned in this chapter for your area of study of class 9th. Triangles, which part? Because there are a lot of things of triangle study. It goes ahead further also in class 10th also. You will study about triangles. You started learning about triangles from class 5, class 6, you know something, class 7 you learned something, 8th you learned something, and 9th what you are going to learn. Here in this year, for this topic, you are going to learn the congruency of triangles. Right? What is congruency? Congruency is exactness, means overlapping, superimposing. That is called congruent. Alike. The vocabulary synonyms for congruencies. Congruent means alike, the same, and exactly same size. Suppose I am keeping the hands here like this. You see here. You are able to see my hands on the screen. Unless you feel it, it is looking outside as only one hand with respect to this. If you remove this part, so it is looking superimposed both the hands. When you open it, you are able to see it as two hands, right? So exactly all the 5 fingers shape and size is matching and overlapping the other hands shape and size of fingers. So if two things are falling on each other such that they look alike exactly one, as a one shade, one impression or one size, and then same size, same shape is called congruency. So I think you understood what is the congruency of triangles. We are going to discuss the alike triangles which are having same shape and same size. You know, there are two conditions or two things to compare the alike figures. Means they can be of same shape, they can be of same size. They are called alike. Exactly superimposing and matching each other. They are called exactly or congruent. Means sometimes what happens, you may have same shape but not size. Sometimes you may have same size but not shape. I think you understood the difference, right? Same shape can be, you can imagine in your what you can say, regular visualization of certain examples. A mother resembles the daughter. Daughter can be same shape in appearance and face, all this, but size are different. Mother will be height, looking age, and daughter will be small in size. But faces resembles that. By seeing the girl, we can understand that she is her mother, or by seeing mother, we can see this girl is her daughter. That is same shaped persons. In mathematics and compared to objects, we call the triangles can be of same shape. Let us see what is the same shape figures, right? So we are talking about the congruency, means I told you exactness, same shape and same size. Always remember, exactness satisfies every condition. Means they must have same shape and they must have same size. They are called congruent. So what happens? Congruence. This is the word. Exactness. Exactness means it comes under two parts. Same shape and same size. Okay. Now same shape, it is symbol for this, and same size, it is symbol. So both are merged. This is symbol for congruency. Similar, right? Same shape means similar, and same size means equal. So this is the symbol for congruency. I hope both are matched, right? This case use this one and this use this one. You know this same shape is equal to same shape is this one, similar. This is similar shape and both are merged. This is congruent. So if I take triangle, triangle 1 is congruent to triangle 2. Then what happens? Triangle 1 is merged on triangle 2. It looks to be same. There is no difference. So on this only triangle 1 is there. On this only triangle 2 is also there. You look to be both are same. They are superimposed. Superimposed. Exact. They are on each other. You can't, unless you open it, you can't identify that. I think you understood what is congruency of triangles. So triangles which are having same shape and same size are called congruent triangles. So any figures you can compare with respect to the shape and size. If it is the comparison related to triangles, they are called congruent triangles. If it is compared to relation of the comparison of quadrilaterals, congruent quadrilaterals, congruent pentagons, congruent hexagons, like that you can say. So congruency is the right same shape and same size. Both are included in congruence. So automatically congruency leads to both. Right? So it gives to same shape and same size, and automatically the symbol for congruence. This is a symbol for congruency. So we are talking about the congruency of triangles. It can be extended to any shape, any size. I told you, like mother and daughter, father and son. Suppose you talk about, they are similar figures, mother and daughter, same shape. So they are called similar, same shape, but different size. So they are called similar figures in terms. So mother is similar to daughter, that you can take, right? But when you talk about, have you noted this part? Note it down this part. We'll proceed ahead. I am giving examples. Then actually, how the congruency exists, what are the types of congruencies, how we'll verify the triangle is congruent to that triangle or not, according to measures of sides and angles, because there are 6 parts of triangle. So any 3 parts of one triangle are equivalent to other 3 parts of other triangle. Automatically other 3 will be matched. That's why, because there is one-to-one correspondence between sides and the opposite angles, and angles is opposite sides. That's what we discuss further. Now we are going into the introductory elementary stage of what is a congruency. So noted, all of you. Can I proceed to next one? Erase this part. Okay. Now see here. You understand what is the, when we compare the congruency of 2 triangles. When 2 triangles are given with respect to their sides and angles, we can verify for its congruency. Right? We can verify for its congruency. Then what are the conditions of criteria or criteria of congruency? Like that. Suppose there are identical twins. Do you know this part? Maybe in science also you have got this word. Twins who are of same shape and same size, identical twins. Right? So generally you can say the 2 boys or the 2 girls, generally they will be like this. So same shape, you can't discriminate them who are that and same size. Unless they says that here also same shape and same size. So exactly superimposing, they are exactly same and superimposed figures. See, in maths we use the word figure because we use the shapes of the objects like triangle, quadrant, like that. In daily life we use the persons, so that we can't use them as shapes, same appearance or same structure, like that we can say. So if such cases, the identical twins is the best example of congruent. So identical twins is an example for congruent figures. See, we are talking about congruent figures. Any shape can be, any size, any number of sides like that, right? For congruent figure. Now we are talking about the triangles of congruency. So we have to see their respective parts, how they are equivalent to each other and how their shapes are equivalent. So what determines the shape of the triangle? Suppose I want to take acute angle, obtuse angle, and right angle. What determines the triangle? So the angle. Clear or not? So if you compare the angles, then it gives the shape. And if you compare the sides, it gives the size. Are you clear? So if you talk about the sides length, it is talking about the size. If you talk about the angles equality, it is talking about the shape. So when you are talking about the congruency, you have to ensure that the respective sides and angles of one triangle, because a triangle is not alone a side or not alone an angle. It is the combination of both sides and angles which have one-to-one correspondence between the existence, right? So if you talk about the congruency, it is the study of sides of one triangle with the sides of other triangle, and it is the sides comparison of the angles of one triangle with respect to angles of other triangles. Are you clear? So when you talk about the congruency of triangles, you must ensure that the two triangles have respective sides equal and respective angles equal. So in case of congruency of triangles, because we are restricted to congruency of triangles only, right? We are not talking about other things, right? We have to deal with shape, angles, sides of both the triangles. Right? In case of congruency of triangles, we have to deal with shape, angles, and sides of both the triangles. Then how we will be discussing them? Do we have to check every side and every angle, right? Or do we have any shortcuts, or do we have what you can say alignment of sides and angles at a time? Or how many sides to be tested, how many angles to be tested, and what are the criteria for which angle to be tested, which side to be checked? So those are parameters, and they are called criteria of congruency of triangles. How we will establish them, and what are the results once we establish the congruency? What we will be benefited? What is the outcome once the triangles are said to be congruent? These parts we study now. Are you clear? So note on this part. Okay, noted? Right. Now we continue. Now see here, what I told you, the symbol for congruency is one similar and equal, right? So similar is meant for angles, angles of triangle 1, similar to angles of triangle 2, and sides, right? Measures. Sides measurement of triangle 1 is equal to sides of triangle 2. That is measures. Right? You know, since there are 3 angles and 3 sides of a triangle, right? So do we need to check all the 6 parts? No. Suppose if I have a subject correspondence, that if I get maths 50 marks, then I'll get English 60 marks. So it is the ratio, 5:6 is the my ratio. There is a correspondence between my maths and English performance. So if I know maths marks, can I find English marks or not? If I know English marks, can I find my maths marks or not? Because they are related. Same way, in a triangle, you know, we already know that angles and corresponding opposite sides are one-to-one correspondent, are one-to-one corresponding, right? Opposite to big angle there is big side, opposite to small angle there is small side. The ratio of small a by capital A or as A, BC is equal to small b by CA is equal to small c by AB. These are, A is the side and BC is that. Similarly, A opposite what comes BC side. This is a angle A, right? Angle A, this is angle B and this is angle C. So opposite side and ratio of opposite side angle. If you reverse also no problem, because ratio can be revertible also in any way, but it has to be, if you interchange the sides and angles also same. You know an example, in a right angle triangle, you take this as right angle triangle ABC, angle B is 90. So automatically you know A and C are acute, because in a triangle some of the angles must be 180. Are you clear? So opposite to angle B, the side is bigger is hypotenuse. You know, that's why by Pythagoras theorem, hypotenuse square is equal to sum of the squares of other two sides. That means hypotenuse is the largest side or not? How? Because opposite hypotenuse, the angle is largest in the given triangle. So there is one-to-one correspondence between sides and the opposite angles, as well as angles and the respective opposite sides. So you know the relation between them clearly, because they are inbuilt by each other's correspondence one-to-one. So you need not test all the 6 parts of one triangle to 6 parts of other triangle to check whether they are congruent or not, right? As a figure, if you draw and you can superimpose them, that's okay. But the figures are not superimposable and you cannot do it by physically. So when you are given 2 shapes of triangles, you are asked to check them they are congruent or not. Yes, you can superimpose them by any shape. If they are looking to be only one, they are congruent. But you may not be given by cutouts of triangles or as the shapes of triangles with respect to cardboard or plastic or wooden or metal, anything. You will be given only triangles with respect to sides and angles. Likewise, you take an example, ABC. You will be given BC value, angle A, angle B. Here, QR value, angle P and angle Q. So how correspondingly they are equal, and what are the things you have to compare? Because in a triangle, we have only 3 things. With 3 vertices only, we will compare the triangle now. We will not use the 6 parts, right? So when you are using the vertices of a triangle with respect to sides, or sides of a triangle with respect to vertices, you have only 3 components to be checked or compared with the other triangles, 3 components. So you are best to compare, you are feasible and convenient to compare the respective 3 parts which satisfy the 6 parts. Like that you have to take. Are you clear? Suppose when I want to cover from here to Prague, I have to cover Wageboard also. So what I will do, on the way to Colony, railway gate, I'll take the right side turn and then go down the steps, then through Wageboard I'll cover the Prague like that. Because otherwise you have to come both ways together, come back. So same way, when you are covering the 6 parts of a triangle to go with the comparison, whether they need to cover all the 3 triangle sides, all the 3 angles of the triangle, you need to take the respective parts such that by any 3 comparison, any 3, in what is the order, that all we'll discuss now. They are called criteria of congruences, right? So any 3 order such way that if you compare any 3, which covers the other 3. I hope you got it, right? So such cases, you need to have some criteria of the triangles. So there are 5 criteria like that, which satisfy the 6 cases, directly 3 sides and 3 angles. So out of these 5 criteria, they are meant for different types of triangles. So for right angle triangle, there is 1 criteria, right? For other triangles, there are 4 criteria. So we cover all of them, and then we get to know once they are congruent, how they are congruent will verify. And once they are congruent, we'll get the other parts also equal respectively. They are called corresponding parts of congruent triangles. So we go with the solving of our applications and testing of our theory knowledge with respect to congruency is, we will be given two triangles with respect to parts. Then you have to align them as respect to, and you have to establish the congruency, and then you have to get the corresponding parts. Then you have to prove the results based on that. I hope you got it. That will be your task. So if two triangles are given with respect to components, you have to align them first, right? They are reverted, inverted, shapes and sizes and measurements of sides are also interchanged. You need not take them as physically. You have to use the logic of aligning the triangles with respect to vertices. And once they are established by congruency by any of the 5 types, you can associate them as congruent triangles. Once they are associated as congruent with respect to the order they are fallen, so there is an order of congruency, because you cannot take congruency as you like, because with the 3 parts you have to align the 6 parts. There is a structured order, as I told you, like a map. You go with page board, then you cover from there and then come back. So in that case, what happens? There is a structured order of alignment of sides with respect to angles, as well as angles with respect to sides. So if you take any 3 parts out of 6 parts, you need to be able to show them as congruent. Once you establish 3 parts, the congruency, other 3 parts, because there are 3 sides and 3 angles, will automatically be equal. There are 2 brothers or sisters. For one boy, she is the mother. Automatically, the sister also, she is only the mother. This is the common logic. So same way, once you establish the congruency by respect to parts of sides and angles, the other 3 parts also will be equivalent. So they are called corresponding parts of congruent triangles. Now you understand what is the procedure and what is the task we are going to have further and how we'll proceed, right? So we are into the introductory part of what is congruency. Congruency is just comparison of the shapes and sizes of 2 triangles, that is 3-sided closed polygons, right? We are restricted to study of the congruence of triangles only for this year. Already you know the importance of angles as well as respective sides of the given triangle. There is one-to-one correspondence. So when you are talking about the exactness of shape and size of 2 triangles, you need to check they are similar with respect to angles, and you need to check they are exactly equal with respect to sides, right? So once they are similar with respect to angles and similar with respect to sides, automatically they are called congruent triangles. So congruency symbol also we have seen, it covers similarity, it covers equality. Exact and same, right? Which are same, they need not be exact. Which are exact, they need not be same. As I told you, identical twins, fraternal twins, father, son, mother, daughter, likewise. So who are identical twins? They come under exactly congruent figures. Same shape and same size. Now, before going to how what is actually congruency to apply for triangles, you know there are triangles with respect to classification of 3 sides with respect to triangles are scalene triangle, equilateral triangle, and what is that? Acute angle triangle. And with respect to the angles, obtuse angle triangle, right angle triangle, as well as acute angle triangle. So you can say there is a isosceles triangle, equilateral triangle, right angle triangle, scalene, acute, and obtuse. So 6 type of triangles are with respect to 6 parts of the triangle. 3 are classified with respect to angles and 3 are classified with respect to sides. So we align all of them with some standard rule by taking the significance of triangle with any 3 parts you will associate. Make others 3 also fall in this criteria to verify they are congruent. So congruency will be shown, and triangle 1 will be with respect to its vertices, triangle 2 will be with respect to its vertices. Once they are equal, automatically other remaining parts also will be equal. They are called corresponding parts of congruent triangles, right? So such cases, what happens when you get to know once the triangles are congruent, they need to be checked with respect to parts, and we have criteria to verify. We'll discuss it further. And once they are verified, automatically what happens? They need to be tasked used with the application, that what are the corresponding parts comes as congruent triangles, CPCT, as well as what all the things will have outcomes once we show they are congruent. So you'll be given two triangles, you have to prove them congruent or verify them non-congruent also, and you have to derive the corresponding parts. Among the derivations of corresponding parts, you'll have some results to verify, prove. This will be your task. So for each exercise, you have 5 exercises in this topic, right? 7.1 to 7.5. For each criteria exercise, there is a one criteria of congruency. Like that, you will go. And the last exercise is the combination of all of these. So like that, we'll go every day one congruency and one application. So note on this part, this is totally we have discussed the introduction till now. Okay? Clear? Till it note down, then we'll proceed further. Okay, now we are left with the types of congruencies to discuss, as well as application of congruencies to solve the given task and then use the results to achieve or prove the required question in the given, what you can say, congruency of triangles task. I hope you have noted it, right? Now this is about notes, and before going to the types of congruency, because we discuss each day wise one type of congruency or two type congruencies. It is up to you how you can cover it at the rate of fast. And already I told you, you must be clear with the project how you have to proceed on the working. Already I told you, any cover topic you can take or deleted topic you can take, and take your own activity. It is independent. The idea is yours, should be unique. You can use the resources like Google platforms and YouTube. All those resources you can take. Use any resource from any media, but don't copy as it is. Take your own intuition as well as the innovativeness in adopting the task. And what is your area of other interest with respect to the topic, you can align. You are good at music, use that concept. Good at dance, you can use that project, or you can good at art, you can use it. Or you are good at in PowerPoint or technology usage, anything you can use it. If you do it as group also, no problem, but I need the specification that how many students are doing each group project and what are their contributions respectively, because there is big grading as well as assessment criteria which involves the requirement of all these parameters. So I already told you, some of you are still asking the doubts. I will clarify, there is no problem. Same area of students can join together if you want to have a group project, right? If you want to do independently, it is also good. So you can use notebooks, one-sided white, or you can use A4 sheets and make a folder also, it's up to you. You can create a documentary, you can take a video, or you can take photograph, you can make a collage, anything up to you. But should be relevant to your concept, and the integration must be clearly justified with respect to notes or your the forward as well as presentation, it has to match. And what is your aim of this making the task? That also should be included. So take standards and some examples to go with this, and keep asking me if you have any doubts. And I have given you time for this end of the month. I think it is sufficiently enough for you, because I announced it long back 4 days ago. Still you have time of around 20 days. So you can make it as up to 1 month for proper and best presentation from your end. They are subject to check or maybe sent to the board also to be required if it is. So please do with utmost care and standard. This is my standard phenomena of guideline for you to follow with the project. I hope you are clear. Yes. So okay, good. Then in that case, we'll proceed further tomorrow. Thank you.